Hello dear learners, our video today, motion in two dimension or projectile motion. We study in previous videos the horizontal motion like car move in a straight road. And we study also the vertical motion like man falling down. Our motion today in the middle. If we throw a stone or fire a cannonball, this is a projectile motion. And the movement looked like this. But the question is, this motion, is it horizontal motion X or is it vertical motion Y? I want to ask my students in this video, Mariam, Abdul Hamid and Muhammad. What do you think, Mariam? Movement like this, is it horizontal motion or vertical motion?
Horizontal motion.
Now Abdul Hamid, what do you think? Horizontal or vertical motion?
Vertical motion.
Muhammad, what do you think? Horizontal or vertical?
Both.
Both. You mean this motion is horizontal and vertical motion in the same time. You are right. So the motion like this is vertical and horizontal in the same time. Like this. We can analyze the motion separately, horizontal and vertical. I want to analyze the initial velocity of a cannonball in two components. Horizontal components of initial velocity Vix and vertical components of initial velocity Viy. First, let's start with horizontal component. We start with initial velocity Vx. And this velocity is not changing in horizontal component. So the acceleration is zero. And the equation of horizontal component is Vx it's equal dx over t. Vx is the initial velocity of horizontal component and the unit for it is meter per second. Dx is the distance of horizontal distance, yes, and t is the time. The unit for the time is second and the unit for the d is meter because it's distance. The second component is a vertical component. In vertical component, the velocity is changing and the acceleration is a gravitational acceleration g. But we consider the positive direction is up and the negative direction is down. So the acceleration is a negative because it's down. And the acceleration A, it's equal minus g because it's down and it's equal minus 9.8 meter per second square. The equations of vertical motion are the first equation. We have here V Fy, which is the final velocity in the y component. In the vertical component, it's equal minus g multiplied by t. Minus g is the acceleration multiplied by t is the time, plus Viy. Viy, the initial velocity in the vertical component, in the y component. The second equation is dy, which is the distance in the vertical component, it's equal half times minus g, the acceleration in vertical components, multiplied by the time squared, plus Viy, the velocity in vertical components, the initial velocity in the vertical components, multiplied by the time, multiplied by t. But we see now that distance in vertical components, it's the same of height, it's the altitude. So we can write instead of dy, we can write h, the height, the altitude, and the unit for it is a meter. The third equation is Vfy squared minus Viy squared, the final velocity in vertical motion squared minus the initial velocity in vertical component squared. It's equal to times minus g, which is the acceleration, times dy, which is the distance in vertical components. Instead of dy, we can write the height h, which is the altitude, and the unit for it is a meter. Thanks a lot for your listening. Until this video, we study part of kinematics. In the next video, inshallah, we will study a new concept of physics. See you. Assalamu alaikum wa rahmatullah wa barakatuh.